Mapping the Collatz conjecture into two-adic space reveals a dense, fractal-like tree structure. We apply rigorous constraints to extract meaning from this complexity. We define two starting parameters by embedding the shortcut Collatz branches, mapping x to x over 2 and x to 3x plus 1 over 2 as the generators g0 and g1. As the diagram expands, these generators act on the two-adic Bruhat Tits tree, T2, anchored at the base vertex v0. Any binary parity word of length n determines a specific matrix product, mn, formed by multiplying these generators in sequence. We need to determine if this embedding translates the erratic symbolic dynamics of the Collatz map into a clean geometric space. Translating 3x plus 1 into the projective general linear group over the two-adic numbers forces the chaotic sequence to adhere to strict geometric and algebraic rules. Evaluating these matrices on the vertices of the Bruhat Tits tree reveals that the vertex-level geometry is too coarse to detect the parity word. The dynamics instead factor into three distinct complementary layers. This roadmap defines how they interact. Track 1 is the radial projection. This geodesic purely tracks the trajectory length, represented by the depth variable n. Track 2 is the boundary action. This isolates a horospherical coordinate that encodes the full parity word. Track 3 is the Levi decomposition, providing the algebraic realization of these dynamics within the Borel subgroup. These three verified layers fundamentally decompose the components of a Collatz trajectory into highly specific geometric and algebraic sectors. In the first layer, we evaluate the matrix product Mn on the base vertex. Taking multiple distinct parity words, the Bruhat Tits tree shows different branching paths. Computational verification shows every path of length n collapses to the identical vertex, Vn. The lattice algebra proves this, simplifying to z2e1 direct sum 2 to the power of n z2e2. Because the result depends exclusively on the length n, the distance between vertices generated by same length words is 0. The vertex projection erases the odd-even distinction. While the matrix terms un and cn hold the sequence data, un is a unit and cn is removed by the integral basis change. The sequence v0, v1, and so on forms a unique, word-independent geodesic ray. This clarifies a common misconception. The Bruhat Tits vertex projection is blind to the parity word. It registers only the trajectory length. If the vertex discards the sequence data, we must locate where the Collatz parity information survives. The matrix Mn is upper triangular. We isolate the top left element un and the top right element cn. We define the horospherical coordinate chi-n as the ratio of cn to un. This is the coordinate a vertex projection eliminated. On the circular boundary of the tree, we mark a fixed endpoint at infinity and a reference point at 0. The generators fix the point at infinity, but the coordinate psi-n traces the inverse image of the reference point 0. Decoding the word from this coordinate is not a matter of reading two-adic digits. The recursion introduces a power of 3 twist at every one step in the sequence, requiring a running scalar remainder to recover the data. This unrolls into a closed-form summation, the sum of 2 to the power of di over 3 to the power of I plus 1. Up to a sign change, this is the classical Bernstein-Lagarias conjugacy map, phi. We verified this by comparing our matrix-derived coordinate against the published formula across random sequences. The boundary coordinate psi-n symmetrically preserves the symbolic dynamics described by the vertex. We can characterize this pairing of infinity and the inverse of 0 through standard algebra. Since the m sub n matrices are upper triangular, they belong to the Borel subgroup, which stabilizes the point at infinity. The standard Levi decomposition splits this subgroup into a torus, T, and a unipotent radical, U. This lets us factor the matrix Mn. The diagonal matrix Dn corresponds to the maximal torus. The unipotent matrix Un holds the boundary coordinate psi-n in the unipotent radical. The radial depth lives in the torus, and the conjugacy coordinate lives in the unipotent radical. Geometry and algebra are unified. This completes the 3 tracks of our roadmap. These 3 layers are independently verified components of the Collatz matrix dynamics. The chaotic, branching sequence of Collatz elements cleanly converges into the specific, unified coordinate identified in our geometric boundary analysis. The standard homogeneous space geometry of PGL2 over the two-adic numbers parameterizes the parity dynamics of the Collatz map.